section, we're going to be looking at powers of 10 and scientific notation. So let's start with positive integer exponents on 10. So for example, we have 10 to the power of 4. In order to figure out that 10 to the power of 4 equals 10,000, first write the number 10. Then start right in between the 1 and the 0, right next to the 1, and move 4 units to the right, because it's a positive exponent. Now add in zeros in each of those spaces, and you can see that the answer is 10,000. Another way to look at that is 10 to the power of 4 means that there's going to be 4 zeros after the 1. Now let's look at negative integer exponents when it's to the power, when it's a 10 exponent. So we have 10 to the negative 6th, which is also equal to 1 over 10 to the negative 6th. So you know it's going to be a decimal value. So again, write your 10. Start right next to the 1 on the right side, in between the 1 and the 0. But this time, because it was a negative exponent, move 6 spaces to the left. For negative exponents, an easy way to look at this is that if you have 10 to the negative 6th, you're going to have 5 zeros to the left. So now let's look at an example of this. We have 10 to the negative 3rd, and we want to basically simplify it, find the value of each power of 10. So let's write 10 again, start at the 1, and because we have 3, we know we have to go 3 units to the left, because it's a negative 3. Alright, now let's look at another example. We have 10 to the power of 2. So we can write 10, start in between the 1 and 0, so right next to the 1, and move 2 spaces to the right. 1, 2. And because this is a positive, you're going right. And as you can see, when it's positive and it's a 10 to the certain exponent, you can just use that exponent, and that's how many zeros you should have. Now let's look at multiplying by powers of 10. If the exponent is a positive integer, move the decimal point to the right. So let's say we have 125 times 10 to the 5th. So let's write 125 again. The decimal right now is at the end of the 5. So now we want to move 5 spaces to the right because it's a positive integer. So 1, 2, 3, 4, 5. And that's how many zeros you should add onto the number. And now the decimal place would be at the end of all those numbers. So your new number would be Now let's look at if the exponent is a negative integer, move the decimal point to the left. So for example, let's look at 36.2 times 10 to the negative 3rd. So rewrite 36.2. Now start at the decimal and move 3 units to the left because it's a negative. So you can see that you're going to be adding 1 0, and that's where your new decimal spot's going to go. So your number would now be 0.0362. Now we're going to look at scientific notation. Scientific notation is a method of writing numbers that are very large or very small. A number written in scientific notation has 2 parts that are multiplied. The first part of the number is just the number, and the decimal goes behind the first actual digit, times the second part, which is the power of 10. Scientific notation such as this, 3.5 times 10 to the 11th power, helps write numbers in a smaller, more understandable form, instead of having to write out 3, 5 with 11 zeros behind it, which would take a much longer time.